Hello students, myself Professor Attarde from Department of Pharmacognosy, MGBS Pharmacy College. I welcome you all to this session on acetate pathway, especially about polyacetate malonate pathway. Now acetate pathway and their metabolites, this representation already we had seen in last two sessions. In short, I revise again: acetate malonate pathway, and polyacetate malonate pathway. These are the three patterns in acetate pathway. In previous section, we had already seen acetate malonate pathway, which is giving you the metabolites of terpenoids types, steroids types, and phytohormones type. In the malonate pathways, how your glycerides generates by the formation of fatty acid by using the malonates that we had seen, and which in further with various methods or with enzymes get involved will give the different higher metabolites, phospholipids, glycolipids, and various unsaturated fatty acids, polyacetylens, etc. Now in this session we are going to deal more in detail about polyacetate malonate pathway. This giving you the metabolites, mainly anthraquinone derivatives, with the formation of its precursors endochrosins and modine, flavonoids, which forms with the mixed pathway in which polyacetate plus shikimic acid plays a major role. So we are going to deal with this. Now carbon metabolism, we had also seen it previous part. So this is the same slide which is showing how these flavonoids are coming from shikimic acids, or we see the tannins, other metabolites, how they are deriving, and how mixed pathway is used, that we are going to see in this session. Now polyacetate malonate pathway. This deals with the polyketide formation, imodine formation, endochrosine. These are the metabolite forms of anthraquinone derivatives, and how flavonoids forms, that we'll see. Now we'll first go with the polyacetate malonate pathway for the anthraquinone biosynthesis. Here you can see in this slide how 8 acetate units joins to form the polyketide, which is converted to anthrone and then to endochrosine, then to the imodine and to the derivatives of anthraquinone. So we'll see it over here. Here you can see 8 acetate units. Now this I took it from Rangari. Reference is a textbook of Rangari. Here 8 acetate units means number 8. Acetate is a CH3COH. So this is arranged in this fashion so you can understand how it joins. So ideally this carboxylic group joined to this methyl, this carboxylic joined to this methyl, and like this carboxyl to each methyl, it is written in this fashion. So COH over this methyl, COH to this methyl, like this. So when it joins under the influence of the enzyme, here the various enzymes and steps are involved, which leads to the formation of polyketides. Polyketides means n number of ketone groups are there. So the polyketides with the enzyme and involvement. So once this is formed, it undergoes cyclization, ring closure, and we get the molecules like anthrone, and further it gives you endochrosine. The structure of endochrosine is there is a here you can see one more ketone is added over here than anthrone. So ideally in anthrone there is here this carbon having the hydrogen, and here it is involved with the ketonic. So it becomes the endochrosine. So this is occurring because of some enzyme actions and several steps are involved. So polyketides lead to the formation of anthrone, endochrosine, and finally it is giving you imodine type of the compound. So this carboxylic group is lost over here, which is the imodine. There are several other derivatives of anthraquinone, but these are the starters for the formation of your anthraquinone forms. So ideally in this biosynthesis, anthraquinone synthesis starts with 8 acetate units, therefore the name is the polyacetate. Now this closing, addition and enzyme reaction, this involves malonates, therefore the name is malonates. There are different units which are making it for ring closure or the enhancement of or addition of any groups, therefore the name is polyacetate malonate pathway, and this give rise to n number of anthraquinone derivatives. There are different anthraquinone derivatives forms like alloimodine, rehine, and there are dienthrones, dienthronols, which forms further. So when we deal with the chapter of glycosides, we'll get to know anthraquinones in more detail. Now, mixed pathway means shikimic acid and acetate pathway combined. This leads to the flavonoid biosynthesis. Flavonoids is nothing but C6, C3, C6 type of the compound. Means two benzene rings having 3 carbon intermediates. Such a type of the compound, usually they are called flavonoid skeleton. The intermediate C3, it may be forming ring closure, or it may remain the open chain like a chalcone. So here it is shown the chalcone structure where one C6 ring, second C6 ring or benzene ring with this 3 intermediates carbon is shown. Now first, p-coumaryl S-CoA that comes from shikimic acid pathway, means this molecule. Why this molecule is coming from shikimic acid pathway? Because shikimic acid is giving this compounds due to its phenyl propane derivatives forms in its pathway. We had seen already shikimic acid pathway for the aromatic acid generation, but beside this also it gives rise to C6, C3 type of the compound. So here you can see C6 and this 3 carbon. So this is there. Ideally this is a 2 carbon with its enzyme, and addition is with malonate. So here your acetic acid with malonates, it go on generating, or chain lengthening is essential, or sometimes the bridging is essential, that it is giving you. So this basically is coming from shikimic acid pathway, which basic one skeleton is coming, and malonyl-CoA is also get involved over here, and this gives a polyketide structure like this, which under cyclization give you chalcone. As I said, chalcone is a derivative form of flavonoid which have 2 benzene rings A and B with the bridging with this 3 carbon. So this is called chalcone structure because this ring is not fused. But ring fusure may take place due to some enzymatic action and aryl migration, and that is under it get closed. So this is called isoflavone structure because this B ring is at second position or second carbon of this ring closed part. So here it may giving you flavone structure where you can see B ring is at carbon 1 of this heterocyclic ring. So this is a furan ring ideally. So ideally these 2 parts, A ring and this furan is a benzofuran. This is the one part of your flavonoid. So when we deal with the flavonoid chemistry in detail, we can understand this much better. But here you try to understand that how one part is coming from shikimic acid, that is giving you C6, C3 type of the compound from shikimic acid. So with enzyme binding, it is giving you this form, and chain lengthening occurs through malonate to give the polyketide forms. So here polyketides forms by malonates, and this ring closure is possible in variety of way, and this may remain at carbon 1 or it may move to the carbon 2 like this, and flavonone structure where you can see how this remains as a saturated, so flavonone. So this is different variety of flavonoids form, or it's a derivatives form, but very initial formation is of chalcone structure, and which is giving you different derivatives of flavonoids in its path. So therefore this pathway is a mixed pathway due to involvement of another units from shikimic acid. So this I took it from reference Reason Events, Rangari book and Kokate book. Thank you. Happy learning.